Hi guys, welcome back. From this video onwards, we will start our new subject, engineering mechanics. These are the course contents, statics, where we deal about basic system of forces, coplanar system of forces, non-coplanar, concurrent, and all those type of forces. And we will discuss further more about moments, couples, and free body diagram. And this second unit is a bit typical thing. We have to just get idea about all these topics, then only we can deal with topic actually. And also plane stresses. We will discuss this topic in the last. First, we will start with this start unit, center of gravity and moment of inertia. We will talk about centroids and area of gravity of forces, moment of inertia, and moment of inertia of composite areas. Not only simple areas, we will talk about composite areas also. And after that, we will go to simple stresses and strains, and we will speak about basics of what is meant by stress, what is meant by strain, what is Hooke's law, stress strain diagram for mild steel, then what is meant by Poisson's ratio, volumetric strain, and all those stuff. And again, we will deep dive into this strain energy topic. This is the continuation of these topics, simple stresses and strains. After completion of this fifth unit, we will go back to the second unit, where we will study about types of supports. Actually, I will teach you about these types of supports in the first chapter itself. While discussing this free body diagram concept, I will teach you about types of stresses and types of forces and analysis of stresses using method joints, simple topics. We will cover it off. First of all, I'm starting off with statics. Okay, let's look into our topic content. First of all, getting into the world of mechanics, first we have to deal with system of forces. What is system of forces basically? A collection of two or more forces acting on objects simultaneously. In the sense, there is a body and more than one or two forces acting simultaneously on a body is known as system of forces. Each force has its own magnitude and its direction. Yeah, just look at it. It has its own magnitude and its own direction. It's pointing up, it's pointing down, it's pointing towards left, it's pointing towards right. Yeah. Each force will have its own magnitude and direction. Analyzing and combined effect of these forces is crucial in understanding the object's behavior. If you want to study this behavior of this object, whether it is moving right or left or up or down, we have to solve this system of forces. Then only we will get a resultant force and we will conclude that how this body is going to move. Concurrent and non-concurrent. We will deal about what are those type of forces. Concurrent forces means force whose line of action meet in a single point. Easier to analyze due to its common origin. Examples: force holding a thrust together, tension in a cable. What is meant by concurrent forces? Just consider this is a point. If two or more forces are acting at the same point, that means they have same common point, action point will be same. Then those type of forces are known as concurrent forces. Examples are: if you consider a system of presses at a joint, yeah, the sum of all the forces or analysis of forces will give you this concurrent forces topic. And non-concurrent forces. What is meant by non-concurrent forces? As we just studied about these concurrent forces, by hearing this name itself, you can conclude that there there is this type of forces whose line of action do not meet at a single point. This is for sure because concurrent in the sense they should have a same point of contact. I mean, single action point. So to be a non-concurrent force, it has to be different. Means every force has its own point of action. This is the point of action for this force. This is the point of action for this force. More complex to analyze due to their distributed nature. Yeah, it's somewhat difficult, right? When compared to analyze this type of forces, it's somewhat difficult to analyze non-concurrent forces. Examples where we can observe this type of forces is forces acting on a beam, gravitational force on an extended body. Yeah. Now we will speak about another type of forces. One is that is coplanar and non-coplanar. What is meant by coplanar or non-coplanar? The name itself suggests that coplanar, in the sense, the system of forces acting on a same plane. Those type of forces are known as coplanar. That's what I have written over here. Coplanar forces, forces whose line of action lies on same plane. Same plane. This type of forces are known as coplanar. Simplified analysis of their effect can be visualized in 2D spaces. Coplanar analysis, as they are on the same plane, if you consider what we call its y axis, its x axis, and its z axis, x, y, z. If you consider two forces are in this plane only, that in the sense xy plane only, it's somewhat easy to analyze. If one force is in this plane, other forces are in this plane, in two different planes, then it's somewhat difficult to analyze, right? And we are going to deal with this type of forces also. Don't worry. We will solve problem on this type of forces. I mean, coplanar, both coplanar and non-coplanar. Uh, just, just look at what is meant by non-coplanar also before moving further ahead. Non-coplanar in the sense the forces whose line of action does not lie on the same plane. As I said, right? This this system of forces has an line of action in this plane, in the sense xy plane, and this system of forces has an line of action in zx plane. These type of forces are known as non-coplanar. Requires 3D visualization analysis methods for accurate understanding. Yeah, we need 3D visualization. Even though I try to make it somewhat clear, but it's not clear for you guys because we need 3D representation of how force will act on a body. Then only you will get a clear idea about this non-coplanar forces. Examples where we can look observe this type of forces. Forces acting on a tetrahedral structure. I can't draw this tetrahedral now because it's 3D object. Even if I try to draw, it is going to be somewhat messy. Forces exerted on a wing on an aeroplane. Yeah, it's a complex example. And finally, resultant of forces. What is meant by resultant of forces? A single force that can be replaced by a system of forces without causing any change in the object motion or equilibrium. In the sense, we have a lot of forces. One, two, three, four, five, and up to n forces. N forces you have. Now we are going to consider the summation of all these forces in single direction, and we are going to represent it as a single force. The summing up or multiplying or subtracting these forces will consider to be resultant of these forces. That's what mentioned over here. Finding resultant is crucial for determining the net effect of all forces acting on an object. That's true, right? We cannot directly what we call judge the motion of a body, or for different system of equations we have different methods to solve this system of equations. Yeah, now we will look at some problems regarding all these things. In the sense, first of all, we will look at problems on concurrent and non-concurrent forces, then coplanar and non-coplanar. Then we will try to sum up resultant of forces. Yeah, this simple problem. Find an resultant for the given forces system. Also find equation. See, forces can be said as concurrent, right? Because they have same point of action, same origin. They are rising from the same point, right? These are three different forces. We have to find the resultant of these forces. For finding resultant magnitude, this is the formula. R is equal to under root of summation of fx square plus summation of fy square. And the direction of this resultant can be expressed as theta is equal to tan inverse of sigma fy by sigma fx. Just look at this. Now we will try to find these forces components along y-axis and along x-axis and along y-axis, and also the components of these forces along y-axis and along x-axis. Then we will add up all the forces in y direction and all the forces in x direction, then we are going to find its resultant. Just look at this. This sign convention for different quadrants. If a force is in this direction, then we are going to take it positive in x direction. If the force is in this direction, we are going to take negative in x direction. If this force is in this direction, it's positive y direction. If the force is in this direction, it's a negative y direction. That's what I mentioned over there. It's sign convention. It is a sign convention for system of forces. Just I'm now resolving this force, 15 Newton force along x-axis and along y-axis. Let us assume it has theta opposite to it, sine theta, and ascend to it, cos theta. And the hypotenuse is 15 degrees right, 15 sine theta, 15 cos theta. And it's mentioned over here in problem that theta is 60 degrees. So my x component will be 15 cos 60 degrees and my y component will be 15 sine 60 degrees. Same with 25 Newton also. It 25 cos 30 degrees, 25 sine 30 degrees. Now I got all the forces along x-axis and y-axis only. Now I'm going to sum up all the things. Just just look at here. Signal effects. Sum of forces acting in an x direction. Now I'm going to add up all the forces in the x direction. 20 plus, as it is in positive x direction, I'm going to take it sign as positive. 20 plus and 15 cos 60 also in the positive direction itself. So I'm going to take it sign as plus. But there are when we consider 25 cos 30, it's in negative y direction, negative x direction, right? So I'm going to take it as sign as minus. And I have summed up all the values and I got sigma fx to be 5.84. Now I'm doing the same thing for sigma fy. As all the forces in the y direction are in positive direction itself, so I'm taking sign of every force to be positive plus sign itself. And I have done the summation of all the forces in y direction, and I have found to be found that summation of those forces as 55.49 newtons. Now the formula for resultant is equal to under root of summation of fx square plus summation of fy square. I'm going to substitute these respective values and I'm going to square them and find the summation, and I'm going to apply root for the whole thing, and I got resultant to be 55.797 newtons. Now it's time to find its direction. The formula for finding the direction of an resultant is theta is equal to tan inverse of summation of fy by summation of fx. You have just be cautious with these signs. Now I know this summation fy and summation fx, and I will substitute those values. Tan inverse of fx 55 54.949 by 5.849. Then I will find its tan inverse, and I got theta to be 83.282 degree. This is how we solve a simple concurrent system of forces problem. Now look at this example. Find the resultant of three forces acting on a hook as shown in the figure. As these what we call forces, system of forces doesn't have same point of action, we can treat them as non-concurrent forces, right? This is a typical example for problem on non-concurrent forces. We are going to do the same thing. Whatever type of forces, system of forces it might be, we are going to find components of whole forces in x direction and in y direction. Then we are going to add up all the forces in y direction, all the forces in x direction. Then we are going to take its under root of sigma fx square plus summation of sigma fy square. See, that's what I have found here. For 70 newtons, x component turned out to be 70 cos 25, and 80 newtons, 80 cos 25. For 50 newtons, 50 cos 45. Everything will be mentioned in this diagram. Just don't worry. Angle for every force is mentioned over here, and I have found its x components and y components, and I found its respective summation. and summation fx and summation fy, and I found its resultant. Resultant is equal to summation of uh, fx square plus fy square, and the resultant is turned out to be this much. And by using the direct formula for alpha is equal to tan inverse of summation of fy by fx, we will find its theta value. It's it is assignment for you guys. Just look at the uh, value of direction. How we are going to get the resultant direction? Just try to plot the resultant of this system of forces on this figure itself. Then you will get an idea. I hope this is all for this video, guys. We have discussed a lot about concurrent forces, non-concurrent forces, coplanar and non-coplanar, and resultant of system of forces. Okay, guys, we will meet you in next video. Till then, bye.